Hey Mythbusters! Today we're debunking some classic space myths. Hop on the next space shuttle and let's get to the bottom of these tales once and for all. Picture this. You're floating weightlessly in space, sipping on a cup of delicious hot chocolate, when a peculiar thought pops into your head. Can you scream in outer space? And if yes, would anyone hear that scream?
If you've watched the movie Alien, then you know the answer to this one. You can't hear sounds in outer space.
It's not that sounds don't exist.
It's just that you can't hear them.
There's no one better to clarify this myth than Chris Hadfield. He's been on a couple of spacewalks during his life as an astronaut. And once you're out there in the darkness of space, you can't hear anything.
All you hear is silence. Complete silence.
But hey, just around the corner is a massive ball of explosion, aka the sun. We just can't hear the explosions happening because there's no medium for sound to travel through. It would be quite uncomfortable for an astronaut, though, if they could hear all the noises going on in outer space. Now, imagine you're zipping through space, feeling like a futuristic superhero, when a shooting star passes by your side. But wait, is it really a star? Unfortunately, shooting stars are not stars at all. They are small space rocks known as meteoroids, entering Earth's atmosphere and creating a stunning light show. Oh, and since we're debunking myths, let's head straight for another one. You've probably heard that meteors only crash into Earth on extremely rare occasions, like once every dinosaur extinguishing apocalypse. That's not true. Scientists estimate that about 48 tons of meteoritic material fall on Earth each day. But almost all of this material is vaporized in Earth's atmosphere. The bright trail we see in the night sky is what we popularly call a shooting star. Next time you make a wish upon a shooting star, remember, you're actually hoping on a tiny piece of space debris. It's not so romantic after all. Can we or can we not fly into the stratosphere on air balloons? Apparently, we can. The Earth's stratosphere starts relatively close to the ground, about 7 or 8 miles up from the Earth's surface, but it continues a long way up. If you were to fly yourself all the way into the stratosphere with some type of air balloon, just make sure you have really good equipment at hand. You'll need a special suit and some breathing devices, because air starts to get pretty thin the higher you get. Of course, if you do go all the way up, you need to get a picture of the Earth's curvature. So take a chest harness with you where you can put a special camera or something like that. And how about you live stream the whole thing? That would be a first! Imagine it's been 102 days since you left Earth. You've adapted well to life in outer space, but something weird is happening to your body. You're getting taller. How is that even possible? Don't stress about it, it's completely normal. The truth of the matter is, you're not getting taller. This is what happens to your body when it's not under the effect of gravity. Our body has natural space between vertebrae and joints. On Earth, this space is almost completely squeezed due to the force of gravity. But in space, your body gets some time off of the pushing force of gravity and begins to stretch more and more. So yes, astronauts can grow up to 3% taller when they're on long missions. And here's a curiosity. NASA has that all covered when they're tailor-making spacesuits, of course. This way, astronauts will always have extra space in their suits. Once astronauts are back on Earth, the anti-gravity effect will wear off. So maybe they'll spend a few days wearing capri pants before it fits perfectly on their bodies again. Never have I ever pictured an airplane door bursting open mid-flight and a bunch of passengers being sucked into the atmosphere like flying feathers. Well, I'm betting most of you have had similar thoughts when getting inside a plane. Now imagine if this were to happen in outer space. Common knowledge says that if an astronaut is sucked out of an airlock, this person would be burnt to a crisp. Brace yourselves, because this is not only true, but the reality of it is way worse. According to astronaut Chris Hadfield, this is what would happen. The part of your body in the shade of the sun would experience temperatures of -418 degrees Fahrenheit, while the part of you getting sunlight would burn at around 480 degrees Fahrenheit. Your lungs would collapse, and your blood would start to boil like tea water. So you would burn, freeze, lose your ability to breathe, and boil. Yikes! How many times have you heard that astronauts have to work out every second of every day, otherwise they'll pass out? This is a complete myth. Remember we talked about gravity earlier? Due to the lack of gravity in outer space, our bodies don't have to do any heavy work. Our torsos don't have to sustain the weight of our heads, and we don't have to make any effort to move our legs because, essentially, there's no walking in outer space. Now imagine living like that for 6 months, or even a year of your life. Your muscles could turn into jello. That's why astronauts work out. They'll strap themselves and run on a treadmill, or they'll do some weightlifting in a special machine. This way, their muscles won't feel the lack of gravity too much. They do need to keep hydrated though. You know what? If I was an astronaut, I'd ask NASA if I could take my super soft water flask up into space with me. You've probably heard that space smells like burnt steak or barbecue sauce. Now, as much as this sounds absurd, this myth is more true than it is false. Astronauts obviously can't smell space when they're in it because they can't take off their helmets. They usually smell it once a space vehicle docks and they open up a hatch. Apparently, what causes this smell is the presence of hydrocarbons that float around in space. Who would have thought, huh? Hey smart people, let me ask you a question. Do you really think that if astronauts fly at the speed of light, they won't age a single second? I knew you'd say no. Let's get a few things straight. First of all, we haven't figured out how to operate vehicles at the speed of light. This would require an immense amount of energy, and we don't have the technology to do that. Second, even if we managed to send a human inside a spacecraft that traveled at the speed of light, this person would still age. They would age differently than the people who remained on Earth, that's a fact, but they would still age. Do you lot really think there's such a thing as immortality? Nah. If you've seen the first Avatar, then you certainly remember that humans only managed to get to Pandora because they traveled in cryosleep. In other words, they froze their bodies, put them in a cryobed, and traveled for years without aging. Yes, this sounds amazing, but we still don't have the technology to do that. Our bodies are mainly made out of water, right? And when you freeze water, it expands. That's why you should never leave soda cans unattended in your freezer. Right now, if we froze a person's body, the water inside of it would expand, harming tissues and organs. So no, we can't cryosleep our way into interstellar travel. Not yet, at least. Here's a crazy thought. What would happen if an astronaut took a drone with them on one of their spacewalks? Unless it's a NASA-designed drone, maybe the thing would freeze and burn like humans would if they went into space without a suit. But hey, a person can dream, can't they?
So, you fall right into the heart of the black hole and prepare for a sad end. Well, you don't have to. Falling into a black hole won't necessarily destroy you or your spaceship. You have to choose a bigger black hole to survive. If you fall into a small black hole, its event horizon is too narrow, and the gravity increases every inch down. So, if you extend your arm forward, the gravity on your fingers is much stronger than on your elbow. This will make your hand lengthen, and you'll feel some discomfort, rather significant to be honest. Things change if you fall into a supermassive black hole, like the ones in the center of galaxies. They can be millions of times heavier than our Sun. Their event horizon is wide, and gravity doesn't change as quickly. So the force you'll feel at your heels and at the top of your head will be about the same, and you can go all the way to the heart of the black hole. This myth is busted. The next myth claims we can save the Earth from a giant asteroid with a big bam. The familiar plot is that a spaceship lands on the surface of an asteroid. A team of astronauts quickly drills a hole in it, leaves a present there, and flies away. Then, bam! As a result, the asteroid may break into several pieces and continue on its way to Earth. Well, big chunks of the asteroid fall to our surface, causing a lot of damage. So, our mission is failed. Well, to save Earth, we need a really big bam. not only outside the asteroid, but right above its surface. When the boom happens, the force of the blast pushes the asteroid slightly downward. Even a slight change in trajectory would be enough to make the asteroid fly past the Earth in the future. Done! Oh, and if you made a big boom on an asteroid, you'd never be able to hear its loud sound. Yeah, we often hear the sound of spaceships and battle in space in the movies, but that's just a myth. Sound is a wave that spreads because of the vibrations of molecules. A person claps a few feet away from you. The sound wave begins to push the first air molecule next to the clap, then the third, fourth, and so on until the wave reaches your ear. So, to spread sound, we need molecules like air or water. In our atmosphere, sound waves spread out just fine, but space is a vacuum, so it's nothing here. You can clap your hands loudly there, but there just won't be any molecules that can vibrate and carry that sound. One more myth about asteroids. We need to fly a little farther than Mars' orbit. Whoa, we're in an asteroid belt, and we constantly have to dodge giant rocks and blocks of ice. We got in some dense asteroid cloud. Not true. The fact is that space is huge, and the distances are incredible. All the rocks and debris in the asteroid belt are only 4% of the weight of the Moon, so there really aren't that many of them there. To understand the size of the emptiness in space, look at the collision of two galaxies. There are billions of stars in each of them. If we mix them up, it's unlikely there will be any collisions even here. Another myth is that there's zero gravity in our orbit. Imagine you're in a huge box 10 miles up in the air. Now we let go of the box and it starts to fall. You're falling simultaneously with the box at the same speed. And now it's as if you feel zero gravity. Well, the same thing happens in orbit. The International Space Station is 250 miles above the Earth, and it's falling continuously, though not on the surface of the planet, but around it in its orbit. Its speed at this point is about 4.7 miles per second. It could cross the United States from the west coast to the east coast in just 8 minutes. So the astronauts there are experiencing the same thing. They're just falling with the ISS at that speed. Now, let's look at the Moon. It always looks at us with one side. This means the Moon has a dark side and the sun's rays never get there. Well, that's a myth. The whole point is that the Moon is gravitationally locked to the Earth. There are days and nights there too. It's just that this rotation is perfectly aligned with the rotation of the Earth. So, whenever you look at the Moon, you only see one side. Although there are days when the sun shines there too, so it's not the dark side, it's the far side. And we even have pictures of this place. And there's one of the biggest craters in our entire solar system, the South Pole Aitken Basin. It's as wide as 2 states of Texas. One myth that turned out to be untrue is that people have never actually been on the Moon. This is the original spacesuit of the first astronauts who were there. Look at the sole of the shoe. Some people claim there's no way they could have left footprints like this there. Actually, they could. On the Moon, the astronauts wore extra boots over their suits, and their soles matched the footprints on the Moon perfectly. The astronauts didn't grab them when they left the Moon. They left a lot of stuff there too. They even ripped out the armrests of the seats of the lunar module to reduce its weight. Now, the total weight of human trash on the Moon is about 187 tons, including several lunar rovers, spacecraft debris, rocket stages, and lunar probes. That's like 3 Boeing 737s. The next myth is about summer. The hot season comes because the Earth approaches the closest distance to the Sun in a year. The Sun warms our planet more, and we all have to go to the beach. Well, not true. Let's draw an axis through our planet. It's slightly tilted on one side, and winter comes when our planet's axis is tilted away from the Sun. But over time, the axis tilts toward the hot star. Then its rays shine at such an angle that it gets warmer. It's true, though, that the Earth happens to be at different distances from the Sun. This is because our orbit is not a perfect circle, but slightly flattened, an ellipse. Normally, we think of the distance to our star as about 93 million miles, but that distance may be longer or shorter than 3 million miles, depending on which point in our orbit we pass. Another myth about the Sun is that it's yellow. Well, let's send you into space for this one. You look out the window and it's white. The Sun only appears yellow to us through the filter of our atmosphere. The composition of the air and its thickness just distorts the light of the star. But stars do come in different colors. Cooler stars have bright orange and red colors. These are usually very old stars, older than our Sun. But young and very hot stars are bright blue. The Sun is about in the middle of the spectrum. You've also heard about how, if you take your spacesuit off in outer space, you'll blow up like a balloon. Well, our bodies are designed to function at atmospheric pressure, like outside. But space is a vacuum. Imagine a huge metal barrel, and we sucked all the air out from there. Add to that a temperature of minus 455 degrees Fahrenheit, and you have space. If you could get into those conditions, all the air pockets in our body, like our lungs, would start to expand. So you really could blow up like a balloon if it weren't for our elastic tissues. They stretch and bend, so you keep your body size. You'll have enough oxygen in your body to last about 20 seconds. Then your brain will begin to starve and soon you'll pass out. So you won't blow up, and you won't even freeze because you'll be in a vacuum. It doesn't conduct heat. For example, water conducts heat very well, and you feel cold from it instantly. But you feel better in the air of the same temperature. If you're in the vacuum of space, the super low temperature won't be a problem for you. Much worse is solar radiation. On Earth, we have a shield against radiation in the form of the atmosphere. It blocks the harmful rays. In outer space, you would be defenseless. Another myth is related to cell phones. People think that when you dial your friend's number, your phone sends a signal into space. There are a bunch of satellites out there that will pick up your signal and reflect it like a mirror right into your friend's home. No, not true. However, there are satellite phones in the world that work that way. But when you make a cell phone call, your signal is transmitted through a system of cell towers from one to another until it gets to your friend's phone. Now, as much as we love epic space battles with blasters cutting through the black void and causing cheerful booms, that's not exactly what happens when something explodes in the big black. Space is basically vacuum, meaning it has no oxygen. And oxygen is an essential part of any process of burning we have here on Earth. You might argue that stars can burn and explode into supernova, but that's not exactly true either. Stars don't rely on oxygen, so they're not burning. There are constant thermonuclear reactions going on inside them. So a spaceship can only explode like that if it has a nuclear power plant installed in it. If it doesn't, then the only special effect you get is a brief flash that disappears in the blink of an eye. Liquid oxygen, which is often on board spaceships, is very quick to burn out in the vacuum of outer space. As for the boom, oxygen plays a crucial role here too. Sound only travels thanks to molecules of air bumping into each other. Since there's no air in space, the whole scene would be pretty much absolutely silent. And that's not a bad thing either. Just imagine how deafening would the sun be if the sound could travel in space. Despite what many sci-fi directors want us to believe, there's no dark side to the moon. Our satellite is tidally locked with Earth, meaning it's always turned to us with one side, while the other always looks away. The sun is much farther from us than the moon, and we're both turning round and round, warming and lighting this side and that in turn. It means that once in every short while, the moon is lit by the sun from either side. It's just that we can't see it from where we are. While things appear weightless in outer space, there's actual gravity all over the place. It becomes weaker the further you get from a heavy object, like our planet, but it's still there. In fact, there's not a single place in the universe that isn't affected by gravity of this or that cosmic object. Everything that has mass has gravity as well. Yes, even you and me. But space objects are so massive that they tug smaller things towards them. That's why the planets of the solar system orbit around the Sun, and our whole Milky Way galaxy orbits around its own center. Scientists believe there's a supermassive black hole there, about 4 million times heavier than the Sun, which keeps all the stars and systems from flying apart. Our movie hero leaves the orbit of Mars on their trusty spaceship and heads on towards Jupiter. Their face is grim and determined, even though they know what threat awaits them ahead – the asteroid belt. They pitch and yaw, dodging the asteroid flying at enormous speeds toward the spacecraft, but one of them still hits it. No, just a scratch, thankfully. Finally, our hero leaves the danger zone and wipes the sweat from the brow with a shaking hand. Sounds familiar, but couldn't be further from the truth. Asteroids in the belt between Mars and Jupiter are so few and far between that if you ever travel through it, you might not even encounter one the whole way. There are about 1.5 million sizable space rocks flying there, give or take 500,000. But let's not forget, space is a vast place. The distance between two asteroids of any significant size would be millions of miles. So a space chase with two ships weaving between floating rocks would be quite boring in there. Space is often depicted as a black, cold, and desolate place, especially when a movie astronaut leaves the safety of their spaceship. Everything about this description is okay, except for the cold part. It's only true if you find yourself in some really far corner of our galaxy that has no nearby stars. But if you're, for example, in the Earth's orbit and directly facing the Sun, the temperature in the cosmic vacuum could reach a scorching 250 degrees. That's why spacesuits are white. This color reflects light better than any other. Still, the temperature at your back, which isn't exposed to the sun's rays, can be really freezing indeed. Heat doesn't spread equally through space, so if you're not turned towards a heat source, you get very, very cold. Speaking about the sun, it somehow always appears yellow in movies. The fact is, the color we see from Earth is an optical illusion created by our planet's atmosphere, just as the blue sky during the day. The light from the sun spreads in the atmosphere and gets distorted, making colorful spectacles at dawn and dusk. In the vacuum of space, there's nothing to reflect the light, so the sun appears as it really is, white. That ball of glowing gas is that hot. There's a bright flash in the sky, followed by a tail of smoke, and a red-hot space rock crashes into the ground, leaving a huge charred crater after impact. Well, although the smoky tail and the crater are partly true, meteorites don't really have a chance to become that hot while falling. Meteorite is an asteroid that somehow entered the Earth's atmosphere and survived the friction enough to fall on the surface. This happens pretty often, we just don't usually see those rocks because they're normally quite small and fall into uninhabited areas. But even if one falls within a city, the crater would appear because of the sheer speed of the meteorite, not its heat. They do get much hotter because of friction, yet not so much as to burn everything on the ground on impact. As much as we want to believe in instant communication between spaceships and planets, it's not possible, at least not yet. Modern communication systems rely on radio signals that have a pretty slow speed compared to the vast expanses of space. It would take years for such a signal to travel even 1 light year, let alone hundreds and thousands. If you want to send a message to a galaxy far, far away, be prepared to wait a couple of millennia and then a couple more to receive a reply. On that note, space is not as crowded and full of events as is often shown on the silver screen. It's mostly a rather lonely place where planets, stars, and other objects are separated by billions of miles of nothingness. Even if you have a spaceship that can travel at the speed of light, most of the time you'll only see black void full of stars and planets far away. The distances are enormous out there, even between the closest objects. For a better understanding, the Moon, which you can see so well on a clear night, is about 239,000 miles away. It's like traveling around the Earth almost 10 times in a row. Warp drives that can distort space-time and get you to a distant corner of an alien galaxy in the blink of an eye, that's a staple of any space opera. Spaceships capable of such a feat are always shown as instantly accelerating from zero to faster than light. According to the law of physics, people on board should, well, at least be pushed into their seats hard. More strictly speaking, no one would be able to survive such an acceleration because it's too many G's on a fragile human body. Until we find a way to reduce the effects of overload, we can't even start thinking of space warps. Water isn't the rarest and most precious resource in the universe. In fact, there's a humongous space cloud several million light-years away from us that consists entirely of water. Its reserves would be enough to fill all our oceans 140 trillion times over. And many planets, some even in our solar system, seem to have liquid water on them. The most precious resource in space is life, and that requires a lot more stuff to appear than just liquid water. Astronauts are often shown working out on the ISS and sci-fi space stations, and that much is true, they do need physical activity. But the reason isn't that they need strong bodies to work in space. The gravity out there is much weaker, and astronauts don't use their muscles as much as on Earth. So when they come back to the surface, gravity hits them as a sledgehammer, and their bodies feel squishy. To alleviate those effects, they train every day. Although they say we can see millions of stars on a clear starry night, that number is much more modest, about 3,000. All the rest are other objects that are also luminous and mistaken for stars, planets, distant galaxies, and even artificial satellites. They're simply being illuminated by real stars, just like the moon, and become seen. But because they're that far away, we can't tell if they're stars or not. Still, you gotta admit, it's all still pretty cool.